Good morning, all. My name is Vaibhav. So in this demonstration, I will show you my source code and the analysis of the both algorithms for the closest pair of points problem. So in this, we compared with the two algorithms, that is a brute force algorithm and the closest and the divide and conquer algorithm. So coming to the source code, I used the modules of random, time, math, pandas, matplotlib for the time analysis, for the calculation of the distance, and the pandas is for the graphs, and the pandas is for tables, and the matplotlib for the graphs. So coming to the main algorithm, I used the function of Euclidean distance for getting the distance between 2 points. And coming to the brute force algorithm, I used it here as discussed in the class. It will compare each point with all the other points. So the runtime analysis is like n squared. And then we use the divide and conquer algorithm here, and it will I use a helper function because to recursively divide and merge them to get the results. And the runtime will be n log n. It will be linear. And then I use the generate points function to generate the random points from the Python. And then I use the run experiment. This is the main algorithm where you give the input size, and it will go through the brute force, and it will go through the divide and conquer, and then it will give the results, and we compare them with the runtime analysis, and this one to build the table, and this one to get the graphs. So I given only 5,000 input here because we can't execute and show you the results of 100,000 right now here within the limited period of time. So I gave only 5,000 here, and I gave m is equal to 10. It will go through 10 iterations. So I'm executing it right now, and then in the iteration one, it generated a sample generation points of 5,000 points, and the brute force algorithm, it gave the shortest pair of points is these 2 points, and it gave the distance of 236, and the divide and conquer, it also gave the same answer. Both are matching, and this is the graph. Uh, the graph is more visible and comparable when we use the more input sizes. I included them in the source code and results. So for the both algorithms, they're given the same answer, same distance, but in the final table, you could clearly see the C1 constant is 7 for the brute force. Divide and conquer is only 4. It's almost half within the limited and very short input. But if we include the 100,000 and we increase the number of input size, it will be exponential for brute force and linear for divide and conquer. The analysis shows very clearly that for the more and more input, divide and conquer is very best. Thank you.